Thanks for joining us again at Nomad PDU. This is part 2 on charging the Nomad and a little bit more complexity to it in this tutorial. Again, let's talk about the basic AC/DC charging and when you might have multiple units of Nomads involved. And this would happen typically if you're out camping and you've all got a Nomad each and you might have forgotten certain power sources and you might be limited to charging. What are your options that you can do? What you've got to remember again is, like I said, your maximum charge rates are regulated as 25 amp. If you're using unregulated solar poles here, there's a maximum of 10 amp that can go at any given time. Across the unit entirely, totally charging rate at any given time is 25 amp, and you could split it between the regulated and the unregulated, okay? That means 15 can go into the regulated, 10 can go into the unregulated, but it cannot exceed that by any amperage at all because you will end up shutting down the unit. Okay, what will happen when you start to get a lot involved in these charging sort of options, there's a good chance you might be able to short the unit out. We're going to talk about resetting that shortly and show you a dead short live while we do it. So let's look at the AC/DC options. I've got one AC/DC charger plugged in here, for example. What could I do with this? If I wanted to plug this into two Nomads, I can use a Y lead. The Y leads are really great to use for a number of reasons. You can use a Y lead in this situation and plug in two Nomads into the one 8 amp AC/DC charger and basically share your charge. You might have a friend and you want to charge at one of these units at a caravan park or something like that. So now you've got two units charging. I know the maximum going to these units is 8 amp off the 8 amp charger. It's going to split. This might take 3 amp, that might take 4. Just depends on the needs of each of the units. You might have a load on one and no load on the other, but this is quite happy now charging and splitting it between the two here. If I was to disconnect this, then literally I'm going to have a connection between this and that, and that's how you'd set up a parallel, but it's not something you'd leave on in a consistent situation because you can actually imbalance the unit. So I'm just charging this for an example, showing you that an AC/DC charger, one of these, is charging 2 units. What else can I do with the Y lead? I could actually reverse this and say, let's say I've got one Nomad and I want to charge it up quickly, and I've got 2 AC/DC chargers and my friend's Nomad is full. What I could do is turn this around the other way, and this is why the power analyzers are really great to have, and they're handy because you can see what sort of charge rates you're getting. So I'm going to take that one there and I'm going to take another AC/DC charger. Now if you do this, make sure the chargers are the same. Don't use different chargers and different chemistries, you're just asking for trouble. So I'm going to take this one here and I'll plug it into the unit like so, and now that should be charging around 15 or 16 amp. Now if I wanted to make sure of that, what I do is I take my power analyzer, which we showed you in part 1, and then we can say, let's see how much it's charging at. I can see coming out of the unit, it's still 12.63 volt, perfect. Plug it into here, and we're going to see what amperage it's going to put in. So at the moment, this is charging quite, well, here we go, there we go, it's charging again. It's charging at about 12, 13, 14 amp is charging it. So that's what the analyzer is great for. And when you're doing this, you've got to also remember that you sometimes can have connection issues when you have a lot of Andersons in play. Just make sure the connections are all good. So this situation here, if there was an issue with the connection, it would show up nothing on here. As you can see, that's a faulty connection on that one there. So I'm charging one unit with 2 AC/DC chargers and getting a fast charge on that, and I know the maximum I can charge this at is 25 amp. Nothing else is on the unit. So that's using the AC/DC here. I'm just going to unplug this and I'm going to plug in one of the Nomads with the charger because there's a lot more complex things we can get involved in. So let's plug that in there. So now this is charging it at 8 amp. You might have 3 Nomads because you've all got a Nomad each. This happens quite often now. And you want to say you've only got one person who's got charging capacity, the rest just bought Nomads and nothing else. Could you charge these in a very sort of funky way? Yes, you can. But if you've got 3 solar panels and 3 chargers and 3 DC chargers, well, there's no real need. What you might find in your own vehicle, you might have 2 Nomads, and if you're going to charge 2 Nomads from your vehicle, you could use the Y lead and split your DC-DC into the 2 units. That's the way that I would do the 2 units. So it's just going to split. If you've got a 20 amp DC-DC in your car, split it off and you'll be able to charge the 2 units because that's a regulated source. Plug it into the red Andersons. There you go. Now, what's another way you could do this? Okay, if you've got another AC/DC charger, what you could do, let's pull this out now. And okay, This is where you could use, not the way I would do it, but these are all things that you may come across that you might need to do on occasion. You could take yourself a pocket inverter. We spoke about pocket inverters before. You can plug that into your car. You can take your 240 charger and plug it in to the inverter, and then you can take your, unplug this, which is the wire lead. Okay, I could take this and plug it into here. Okay, that means I'm going to have, you've got to remember when you plug an inverter in, the inverter is going to tax this unit because it's going to have a conversion, because it's going from taking this to a 240 volt or 220, and then you're converting it back to 12 volt again. So you're losing efficiency in that transmission. So again, she's charging, and if I pull this out, again, I can plug my analyzer in here and then plug it in, and I can see what it's doing, and it's charging at 7.95 amp at the moment. So I could do this as a solution when I'm driving, and that's no problem, but it's not a permanent solution, because you've got to remember this little fan in it. If you left it for 24/7 for 5 days, you probably end up burning the little inverter out. So that's not a long-term thing, but you can actually do it. As you can see here, the red light is on, so it's charging, and over here it's charging, that's fine. And what you'll see here is this is actually drawing 11.3 amp out of this unit, converting it, and then you're getting 8 amp going into here. The way I would do this, if I have a DC available, let's unplug this just to get this out of the way, is the Sigga DCs that we have been extremely popular because you've got a proper dual setup without any of the hassles of all the fancy wiring, and you can use them in a number of ways. So you've got your Sigga DC plugged into your unit, and let's get these wire leads out of the way. But let's just say, for an example, I wanted to run the two of these together, maybe a third one. I just grab my 5 amp Sigga DC here. So this is a regulator. So this is basically a charging module, or voltage stabilizer, you can call it. And this is a 5 amp, and this is the preferred way. Is if I wanted to do this, I can plug it in here, okay? And now I can plug it into the second unit, and that's going to give me a 5 amp charge. If you look here, it's drawing 5.71, and I know going into 5 amp module, it's probably going to be putting in about 5 and a bit, 5 just over. Again, make sure, take a pair analyzer, plug it in, there we go, and then I plug it in here. It's charging, and it's charging at 5.15, 5.16 amp, okay? So that's now charging. That's perfectly fine. If you've got a third Nomad, you could do the same thing again. Because remember, all you got to remember with this is what's being drawn out of it and what are you putting in. So at the moment, going in here is 8 amp charger, correct? We're drawing out of it 5.67. So there's more going in than currently going out. When you saw before I plugged the inverter in, it was pulling 11 amp. That relay right will go out because it's pulling out more than is going in. So that's what you've got to remember. So again, if I was to pull out more than the 8 amp going in, this unit would actually show it's not charging. And how can I show you that? Let's just plug a fridge in here. And as the fridge kicks in, it'll pull another couple of amp, and I'd expect that the red light will go out, which it has. See, it's coming up 8 amp. Now that's what we'll get a phone call on now. We'll get an email saying my Nomad's not charging when the fridge is running. That's absolutely not correct. The fact is, I could put a power analyzer here, and I will, just to show you, is that I can tell you what's going in. There's 7.5 amp going in, and there's 8.8 going out. So why would the charge light go on? It wouldn't, because the Nomad has to supply another amp over above what's going in. So it's actually not charging, but what it's doing, it's putting 7.5 amp in, and it's taking an amp out of the Nomad. So technically speaking, the Nomad is going to slowly drain. It might take 3 weeks to drain it if you've got that plugged in, because your fridge is going to cut out when it gets to the thermostat setting. But that just shows you that there's still charge going in. If I pull the fridge out, the charge light comes back on, because there's more power going in than there is going out. Now what I can do is also look at, and this unit here is this setting 11.7, and then I'm going to go to the third one, and I'm going to plug that in again here. I'll plug that in there, and you can see the red light's gone on. So now I'm going, charging that at 8 amp, I'm charging this one at 5 amp, I'm charging this one at 5 amp. One thing I will point out is the fridge, this fridge is not an expensive fridge. This fridge will actually cut out at about 10.6 volts. So if I was to plug this in over here, this has got 10.9 on it. This fridge, it's nothing wrong with the fridge, there's nothing wrong with the Nomad, but it doesn't have enough voltage to kick that in. It's just got the LED light on here. So that's a fridge issue, it's not a Nomad issue. That means the fridge has a voltage operational range that's about 10.6 and above. It's around about 10.8, 11 to 12.6. But what I could do in this situation is say, okay, I'll pull it out, and then I'll take a unit here, which is say 11.5. I can plug it in there. And what will happen is that it'll start, it'll go F1 and then it'll reboot. So now that's got enough to kick it in, and I could plug this into any one I wanted to. I could take this out, as you saw before. I can run it from any one of these units. You just got to remember how much is the unit drawing. So how much is going out, how much is going in. What's the maximum output of any of these units at any given time is 20 amp. So in this complex setup here, theoretically, you could run another 4 or 5 Nomads if you want to, and you've actually got 300 amp hour of usable power, and you're charging one of the units, and it's charging the second and third, and as long as you keep this one topped up. In this situation here, I've got an 8 amp charger plugged in. I could also now plug my 200 watt unregulated solar panel into this unit here, and then that's going to put in what, say 18 amps going to go in, and then that's quite happily drawing out 5, and then that's drawing out 5 there. So this is going to stay topped up, and it'll keep supplying these ones, and I could run 2 fridges off the other one at the end there. So the Y leads again are really valuable, because you might, like I said, you can charge, you know, from 2 AC/DCs, and you can double it up and put it into one Nomad, or if you've got one AC/DC charger, you can split it. If you've got one DC/DC in your vehicle and you wanted to split it, you could split it. And then you could also use the Y lead if it's not being used. You can plug it into this, or we'll just do this one for example. Just plug it in here. I've got that, and I run 2 fridges off it and keep all my other ports free. Now that's the way I would do it, and the reason I would do that is because I don't have to worry about all the other ports being used up, and I've got all these other Nomads that I can still use, and they're all still charging. And you can run 2 fridges off to one of those, like that. With fridges, when they shut down because they've gone over their voltage, in other words, what happens is that their voltage range they'll operate from will be different on each fridge. A lot of fridges will run down to say 9 volts. Some of the top end fridges will run down to 9 volt and less, and that's fine. Is that you need to give them about 1 or 2 minutes rest, and then you can plug them in and they reset. That's typically what happens there. So this is when you're charging the Nomads in a complex situation. But as long as you remember the basic rules of each unit, what is the maximum charge rate at any given time? It's 25 amp max at any given time in the regulated input. If you're going to split it off and use the unregulated, you've got to remember you only have 15 amp available to charge in there now, because you cannot charge over 25 amp at any given time on the unit. So with unregulated and regulated, if you're using both, again, maximum 10 amp unregulated from a solar panel without a regulator, use the MPPT controller in the Nomad and it'll convert it to lithium charge. You've got 15 left. If you're not using your solar here, then you can run it with a 25 amp in here. What I did want to show you is when you talk about a dead short, and it does happen, and I'll show you how. It's very, very easy to do, and the reason I say that, okay, and again, if you just saw that then, that was showing that there's more going out than going in because there's a conversion there. But what would happen is, and you can see there's actually charge coming out of the unit. But if I was to dead short this, and I'll do it on purpose, let's look at dead shorting it. You see that? So what I've done here is I've done a dead short. Now how did I do that? And it's kicked back in because I've got the charger plugged in. That's how you reset it. So let's take that out and dead short it again. Don't try this at home. But now this happens quite often if you've had too many sherbets when you're out camping. I know that my colleague does it quite often, who's experienced with these, but he does it continually. So that's now shut down. All I've got to do to reset that dead short is put a charge into it. Okay, it's now been reset. There's no need to worry about internal fuses or things like that. So that's what happens if you get a dead short. And if you had a dead short like I did then, and I took the short off, and I had the charger already plugged in, it's already rebooted. The same when you talk about an overcharge. If you do an overcharge, then you've got to draw 1 amp out of it, and that will reset its capacity to charge. So there's a lot of inbuilt smarts, but again, you must read the instructions, because if you don't, you're going to run into trouble, especially when you start to do these complex things. If you're not sure, don't ask your mate who's not an electrician or has any understanding about the unit. You need to come back to us and ask us any specific questions to your needs. And that will save you a lot of dramas when you're out camping. So that's a bit more complex charging. Read the instructions, and any further questions you might have, by all means contact at nomadpdu.com.au.